Hey, hi. Hey, hi. This is Priyanka Singh, and today we are going to talk about a new coding problem, which is binary tree right side view, in which we are given a binary tree and we need to imagine yourself standing on the right side of it, and we will return the values of the node you can see ordered from top to bottom. All right, so here we are given with a tree, and let's suppose you're standing at the right side of that tree and you need to return with the nodes that are visible from this right hand side. So in this case, 1, 3, 4, these are the three nodes that are visible from this right hand side, hence we will return this 1, 3 and 4. All right, and if we talk about one more example, like if we had 6 here. All right, so if we had 6 here, then in that case this 6 also would have been added to the output, because this is also visible from the right hand side, right? So let's see what we can do for this. As you know, for most of the tree problems, um, very basic approach that we use most of the time is recursive. So that is what again we are going to use today for this solution. So for that, all right, so one important topic to be noted here is we are going to use recursive. Next, if you find the pattern in this solution is that we are going to pick only one node from each level, right? We are going to pick one from this, one from this, and one from this. But what if we had 6 here, the way I showed you before? In that case, again, we are going to pick one from another level, which would be 6, right? But we don't have anything in the right hand side of this tree, but we have to take out something, right? Because it would be visible from the right hand side. If we are not having anything in RHS, then there is something in LHS present, then that LHS would be showing up if a person stands at the right hand side and sees the tree, right? So one more thing that I told you just before, second thing is we need to track the levels, at which level we are, in order to pick one, at least one from that entire level, right? So for that, first of all, very basic case is we need to check if root is null or not. Yeah, if root is null, then we will return. Alright, so we need to return this. This is a list containing solution, containing result of the output. So let's name it result equals to new array list. If you have a doubt that why I'm using array list and here it's list, this list is an interface that we can't initiate, and array list is a class that Java allows us to instantiate. So I'll just return result as it is. And next would be I'll run a utility function, because in this case we will be having one more extra parameter defining the level. And at the end we need to return the result, right? And here it won't return anything. We are just going to parse through the elements of the tree, and then we'll keep adding into this res if it is visible from the right hand side. And level, right? So initially 0 is the level, and we are starting with the root of the tree. Okay. Now the thing is, if we need to check, all right, let's do it later. First, we need to check, are we having on the right hand side something? If right is not null, Then in that case, we will run this loop again. Actually, this loop. This is a recursive loop. This is a recursive function. So I'll just write it down first and then explain to you guys. Alright, so here what's happening, here we are going to process the root at whichever node we are currently. Alright, and then we will proceed with the right. If we are having something in the right hand side of that root, then that is for sure whatever is the right view, whatever roots are visible from the right hand side, that will be present in the right itself, right? Otherwise, if it is not present in the right, then we need to look for it in the left hand side. So that is why I have put this line over here, because we need to parse left hand side. Okay. And other thing would be, uh, I need to pick at least one node from each level, right? So I will check at whatever level I am, if that is equal to. So initially, how it would go, like for this, our output is having zero size, and we are at this level, zeroth level, right? So we can add it, right? So yes, if we are not having anything, still we have not picked anything from this particular level, then we can insert our element into the output. So that is what I'll do here. I'll add root dot value. Right. So I added one to it. Now I'll start with the right hand side. So I'm parsing. What I'm doing here is I'm going through it from right hand side to left hand side. Okay. If this right hand side is not available to me, if this right hand side is not available to me, I can I'll go to the left hand side. That is what I'm doing here, right? And then yeah, so if it is available in the right hand side, I'll add it in the right hand side and go to the another level. Otherwise, if it is not available in the right hand side, then I'll go to the left hand side and then search there itself. So this is how it goes. Okay, 134. That's fine. Let's see how it behaves for all the use cases. It's accepted. All right. So that was it. If you found this solution useful, actually I tried keeping it short and simple and very much intuitive. If you guys have something another in your mind, you can just do share in the comment box. And happy coding, and do like, share, and subscribe my channel. Thank you.